Okay, so let's look at an example of how we're going to use Coulomb's law to discuss the forces between two objects. So let's look at this right here. We want to know what is the force charge 1, so we have Q1 here, exerts on Q2 here, and in what direction? Okay, so what is a force? So we're trying to solve for F. I know my Q1 is 1 Coulomb, Q2 is 4 coulombs, and I forgot to give you the distance. Let's say that this is 1 meter apart. So my R is equal to 1 meter. And I want to do F is equal to K, absolute value of Q1, absolute value of Q2 over R squared. And you're going to see why this absolute value is going to be important here in a second when I give you a negative charge. So let's put our values in here. F is equal to 9 times 10 to the 9 Newton meters squared per Coulomb squared times absolute value of 1 Coulomb times absolute value of 4 coulombs all over 1 meter squared. And I don't know if I said in that, now I'm thinking about it, I'm not sure I said in the last video, this R is the distance between charges. So even if I did say it, it's a good reminder. So when I punch that into the calculator, F is equal to 9 times 10 to the 9, I get 3.6 times 10 to the 10 newtons. Now, if you need a reminder of how to plug in this 9 times 10 to the 9, for my calculator, I do 9 exp to the 9. So some of you are going to see that. Some of you may see 9 double E to the 9. Depending on your calculator, if you're not sure, Google it. Take your calculator, type Google how to do scientific notation. So here we're looking at scientific notation. See how to do scientific notation in your calculator. Stop by the Math Tutoring Center or somewhere where they may be able to help you. But if you can't find help, email me and I'll see if I can help you. But a lot of these how-tos will be on Google to see how you can plug these numbers in on your calculator. Now, it says in what direction. So we want to look at this. So the magnitude is 3.6 times 10 to the 10 newtons. And we're looking at what is the force charge 1 exerts on charge 2. So charge 1 is positive, charge 2 is positive. So we know charge 1 is going to push charge 2 to the right. Okay? So that's pretty good. That makes good sense. So now I want to do it with the same situation, but I want to have 1 Coulomb here and a negative 4 coulombs there. Okay? So now if we do the same thing with 1 meter apart, F is equal to K, absolute value Q1, Q2 over R squared. I get F is equal to, you're like, well, it's going to be the same thing. But let me write it out just to make sure everyone's seeing this. This is absolute value. Absolute value of 4 coulombs becomes a positive 4 coulombs over 1 meter squared. So I get an F equals 3.6 times 10 to the 10 newtons. And you're looking at what is charge 1 doing to charge 2. This is 1, this is 2. Well, charge 1 is pulling charge 2 to the left. Now, some of you are like, well, wait a second, had we not done absolute values, we would have gotten a negative. Yeah, but let me humor you a little second. Let me ask a different question. So same situation that we just had, positive charge, negative charge, but I want to look what is the direction of the force that Q2 exerts on Q1. We know it's going to be the same magnitude, so we know our force is equal to 3.6 times 10 to the 10 newtons because of Newton's third law. Okay. We know that's true, and we'll get into Newton's third law even more. Just trust me for right now that they're equal because of Newton's third law. Again, we'll get into Newton's third law more when we're doing motion and so forth. So we know because of the third law they're equal to each other. But now I want to look at direction. So we know that opposite charges attract. So Q2 is going to pull Q1 to the right. Okay? So what I want you to see here is when we do these equations here, we do absolute value to get a magnitude. So we're getting a magnitude here. The absolute value gives us how strong. In this case, how strong is the force? When we talk about magnitude for velocity, we were talking about how fast you're going, what's the speed. We want to use what we know about the charges, the concept. What direction are these charges going to go? That's these points right here and right here are coming conceptually, not mathematically. So you really have to understand the physical science of what's going on to be like, okay, opposite charges attract, like charges repel, and then talk your way through what direction. You're going to see these on the quizzes. You'll see how they interact in real life. So when you're bringing two objects close together, it's how you can get charged particles in the body to interact so you can get imaging and stuff like that. So kind of make sure you got an idea of conceptually, and then make sure you can plug and chug and do the mathematics as well. Next up are circuits, and we're going to look at how we're going to move to current electricity and how these electrons that are flowing can impact light bulbs, Christmas lights, and stuff like that.